weeks ago, I decided it was time I started to play with some of these bigger lithium-ion batteries. Now, it's quite hard to get lithium-ion packs in the UK at the size and capacity that I wanted, so I decided it was time to make my own. My chosen cell for the packs we're going to build are these, the 21700 P50Bs from Molicel. Now these are 4850 milliamp hour cells. We're going to be building batteries in a configuration of either 6S and 1P. So we're going to do one about 4850 milliamp hour pack, but we're also going to be doing some bigger packs as well, which are 6S 2 parallel, and we're going to be building them in a future video on the channel. To be able to build our batteries, we need to connect these cells together in the correct order. Now there are several different ways of building batteries and connecting the cells. You can try soldering them together, but that is quite difficult. You need a big tipped soldering iron to put enough heat into the battery, and by putting that much heat into the battery does come with risk as well. I personally feel soldering is actually quite dangerous on these cells, and the best way to do this is how it's done professionally, and that is with a welder. I spent a bunch of time looking around and investigating what the best options are, looking on places such as Amazon, AliExpress, as well as shops in each country. There are lots of different options available out there. There are cheap boards for as little as £10 or $10, and there are more expensive welders for as much as £120, £150 available on AliExpress as well. However, in all of my investigations, one brand kept getting recommended to me, and that was this, the Keenlab kWeld. Now this is a product that is made in Germany. It is a DIY welder kit, but it does appear to be one of the best options available on the market today, and it comes highly recommended by a number of people who have been using this to build their own batteries for quite a long time. So I popped onto the website, bought the kit, and that arrived a couple of days ago. So, as you can see, we have all the components from the system. We have our foot switch, we have our main control PCB, our display module, we have our fuse and our buzz bars, we have fixings, and we have our main cable set. Now, something to understand about this is the way it works with regards to controlling the amount of current. This welder basically short circuits your battery, which is your supply power, against whatever you're welding. It is simply a device that allows you to very quickly control the outputs on here. So what it will do is control the amount of time that these ends are shorted and provide that power to allow you to weld. In essence, you're just short-circuiting the input supply to the output, allowing you to weld. This is why it's very important that you have an input supply capable of providing enough power for the unit. You're not going to be running this off a 12-volt power supply. You're going to need to be able to run this off either a big capacitor bank. They offer a supercapacitor bank, or a LiPo, or a big lead acid battery. Something, though, to understand about this system is how it controls current, or I should say, how you control the current that the system will draw for the welding. This is basically an electronic switch that allows you to short circuit your input to your output. It has some clever algorithms to get the best possible weld. As a result of that, though, you do need to be able to control the amount of current this system draws, and that is actually done by the cabling. When designing this system, they've actually taken into account all of the length of the cable, the resistance that has, the resistance of this main PCB, and to actually control the main output, you also need to work out what the resistance is of your input supply, and that will then provide you the maximum current that this system is capable of providing. It is designed to work up to 2000 amps. It's not only important that you have a supply that's able to deliver up to that 2000, or at least 1500 amps for a good weld, but you also need to make sure that you don't go over that as well, because you could damage the board. When you buy this, they actually give you a couple of options with regards to these cable ends. You can choose to get it pre-wired like I've got here, or you can choose to do this bit yourself. But as this is a critical element of the design of the circuit, I chose to get it like this. You may also notice that the input supply wires they've provided are very short, and again, that is for resistance, because this system's entire circuit resistance will play into how much current it's able to provide, and as a result of that, if your battery cables are too long, you're not going to be able to provide enough current for the welding. Now, there is a calculation that you can do to work all of this out. It is listed in the manual. We'll talk about this a little bit more later on when we actually do the testing on this, because there is some calibration as well that we're going to need to do. But the basics are, when they've designed this system, they've designed it in such a way that this circuit resistance should provide the right amount of power with a suitable input battery. Now, the next thing we're going to do is put it together. I've actually pre-printed this case that's available from kWeld. It is a free downloadable STL, although you do have to buy the STL for free on their shop. I've printed this in polycarb. We're going to use this for the main system. So what we're going to do is start the assembly process. I'm going to walk you through that here today, and then we'll talk about the actual power supply that we're going to use for this later. To start, we're going to need our PCB. Now, I have to say, this is beautifully made. Here you can see the big copper areas. This is either side of these driver ICs, which is going to control the current from our input supply. We've got big copper areas up here. We've got the copper areas for the buzz bars. Down the bottom down here, you've got your microcontroller. We've got an STM32 F1 series. We've got our power supply down here, our little controller over here, and this is where our display goes as well. That simply clips over the top, and you have the little mounting posts to hold it in place. I have to say, looking at the design and the quality of this board, it is stunning. It is one of the nicest boards that I have seen in a long time. Just the quality of the solder mask is beautiful. If I just spin it around the back, it is really well put together. It's a lot higher quality board than you see from some of the Chinese made stuff that I'm used to playing with. You can certainly see a lot of effort has been put into this board, and as I've said, it's just even the little stuff. The quality of the mask has a real nice look to it. Obviously, that doesn't matter once it's in its box, but as someone who somewhat drools over this stuff, I have to say, I think they've done a really nice job, not only on the design of the board, but the actual implementation as well. The first thing we need to do in the build is mount our display. Now, this pushes onto the main PCB, but you do need to add on these little mounting posts to hold it all correctly in place. So if I just unplug that there, you can see the main display module. That has the pin out along the bottom, and that plugs into these pins down here. But before we do that, we need to put these little mounting posts onto it. So we've got 4 little posts there, and then we've got these screws. I just need to work out which are the correct ones. It looks like it is them there. So what we need to do is pop the screw through the hole, just like that there. Then screw on our mounting. There we go. We're then just going to tighten the 4 of them up. That has our posts going through, nice and straightforward. We then need to mount this onto our board. So that just pops through like that. We're then going to just push down so our connections push in. Pop that over, and then somewhere we should have a few nuts There we go. There's another bag there just with them. And we simply then need to use these to tighten down onto the other side. Then simply going to tighten these down one at a time, just to make sure that it's not going to come loose. You obviously wouldn't want to wrench this down too much, but just enough so it's not going to pop off accidentally. Being careful not to damage any components that you might have around it. Unfortunately, just doing that, I've actually skipped a step that might be important to you. And that is, if you're not going to mount this into the box, there are standoffs included to allow it to stand off the table. You pop them into there, and the fourth one is located under the display. So if you followed what I've just done there, if you're not putting it in the box, you're actually going to need to take the display back off and put the screw back through to put the standoff on. That's why you should be reading the instructions and not just watching me do it in this video. But I did want to just mention that the basics is I've just sent you into a bear trap. But if you're using it with this case, you'll be absolutely fine. The next thing we now need to do is look at mounting our buzz bars. And there's screws and bolts included for this. We have a whole load of bolts here and here of different sizes. We're going to use these ones first. We then have nuts for them, and we also have washers. These are used to bolt our buzz bars to this PCB. This is to help bring the current through, is to ensure that we don't do any damage to this big copper track. Even though that track is really thick, it would be very easy to actually cause damage on this. And as a result of that, they include these buzz bars that allow you to sort of help reinforce this center area of the PCB. Before I do that though, I'm just going to give this little copper area a bit of a wipe with some IPA or isopropyl alcohol. You probably won't need to do this, but as I'm recording this video, I actually ended up touching this copper area with my fingers. I could actually see my fingerprint on some of the areas with the copper, and I just want to try and make sure that we've got this as clean as it possibly can for the buzz bars and not have any fingerprint residue that could corrode or cause a problem over time. I'm probably being a little bit obsessive here. However, I could see my fingerprint on it, so I just want to make sure that I've dealt with it. So, what we now need is our buzz bars. The way these actually fit is that there is the whole line of holes, and then there's a bigger hole at the end. So you can see we've got each side. Again, I'm going to wipe this with a bit of isopropyl alcohol before I fit it onto the main board, just to make sure it's as clean as it possibly can be. I'm not worried about the top end that I'm holding with my fingers because I can clean that afterwards. I'm simply just going to make sure I've cleansed this side of the board. We're dealing with extremely high current here, so making sure everything is as good as it can be is always good practice. There we go. You can actually see the color of the Q-tip there. So what I'm going to do is carefully pop that down and then pop that onto there. The next task is then to take some of our nuts. Now these are obviously not copper, but so I'm not going to worry too much on these with regards to anything like fingerprints. I'm going to pop it through there, and I'm going to pop one through on the other end as well, just to try and locate that properly. I'm going to flip this over, and then the next thing we need to do is install our nuts and our washers to hold this in place. In the instructions, they do show you a specific way to fit these washers. When you look at these washers, there will be one side that looks more squared off and one side that's more rounded. You want to be putting the rounded side against the PCB. That way, it's not going to be causing any damage to the copper tracks when you put the bolts on. So that side is the rounded side. That side is the flat side. It's the outer edge that you will see the difference on. So I'm going to just pop that one onto there with the rounded side down. I'm going to do exactly the same on that one. We're then going to take our nuts. I'm going to finger tighten that down. Same for this one up here. That's now going to hold the bar in place. So what I'm going to do is continue to pop the rest of the screws in, put the nuts on, and the washers, making sure again that we put the rounded side down so we're not going to cause any damage to our PCB. And then we will pop on all of our nuts and then tighten this board down. Just before you tighten up all your nuts and bolts, do make sure that this hole at the end is correctly aligned. You're going to need to be able to pop this bigger bolt through it later on. So as long as that all looks right, you're then able to put yourself an Allen key on and then slowly tighten these up one at a time. You don't want to overdo this. You certainly don't want to wrench it up so you damage the PCB, but you do want to make sure that they are at least tight enough that they're going to offer plenty of current carrying capacity to make sure that they're able to deliver the power that the system needs. But again, don't overdo this. If you were to overdo it, you could damage the board. Just make sure that you sort of nip it till they're tight. Do that one at a time on the first one. And then it is simply a task of doing exactly the same on the other side. So there we go. We have the buzz bars fitted, all bolted up onto the back. The next thing we need to do is install a couple of big screws up here. So we've got these big bolts that they've included in. We've got one that needs to go through here, just like that. And then we've got one that needs to go through this other end hole over here. So these go on just like that. We simply bolt these on directly. It doesn't look like we use washers on this one. I'm just looking at the instructions as I'm doing this. No, there's no washers on this point, but there are in a minute when we move over to the fuse. This is our bolts for our safety fuse, which is included in the kit. So we need to start to bolt these up first, and then bolt these tight to the PCB. And we're going to need to get ourselves another Allen key and a spanner for tightening these ones down. So I'm just going to tighten these up with a 10mm spanner. There we go. So that's nice and tight. We then need the washers. It looks like 2 of these go below and 2 go on top. So we've got the washers and then we've got the fuse. Where did I throw the fuse? Oh, it's next to me, blind as a bat. So this is our protection fuse, rated at 300 amps. This is just going to offer protection for the system should something go horribly wrong. This also is where we will mount our welding wires directly to it. So we've got our output as well as our input on this as well. So to do this, we're going to place a washer on each one. We're going to take our fuse, pop that over the top, place another washer on each one, and then we need to connect our input and output wires. Next, we want to connect up our power input wire. That goes on the left-hand side. These two are actually 2 different lengths. you've got a longer one and a shorter one. So if I just place them next to each other, the longer one goes on the top and the shorter one goes on the bottom. That is because the screw holes are not aligned, so you need the longer of the two up here. So that goes on after the washer, and then you simply pop on your nut, and then we'll tighten that down in a minute. It's the same on your electrodes. Your longest electrode wire goes on this side here. One is ever so slightly longer than the other, so if I just put them next to each other, stretch them out, you can now see that one has come out slightly longer, so it is the longer one that you want for this. And again, you simply mount that onto there, place the nut on top. Before tightening down, what you then want to do is just make sure everything is nicely aligned, make sure your fuse is straight, your wires are straight, and then you can simply start to tighten it down with a 10mm socket or spanner. You might need to do some little adjustments on this as you work through it, but overall, it should be pretty straightforward. You do just want to make sure that you've got it nice and straight, and then as tight as you can. You always have a little bit of an alignment to do on things like this because it always moves as you're tightening it up. Perfectly normal. But that way, there we go. All sorted. Next, it's the next two. So, left-hand side goes our shorter of the two. Now for this one, we need our longer bolt. Fairly straightforward, but we do want washers on this one. So the process for this one is popping our bolt through the top. Pop that through our buzz bar hole. On this side then, you're going to want another one of those big washers that we had earlier. Again, being careful to mount them the right way round. So with the rounded side down, then simply pop our nut on, align it, and tighten that up. What I'm going to do in a minute is get an Allen key on that as well, just to make sure that we've got it tightened down as well as we can. Again, you want to make sure everything is tightened enough that you're not going to have any potential for anything to come loose. No additional resistance in the circuit, but you don't want to over tighten it in such a way that you break anything. And then finally, it's our last electrode. Pop that through there. Pop that through our washer the right way round. Our nut. We'll get this nice and straight with our Allen key. So now you can see I've popped it into the bottom half of the case. It just drops in. There's some little standoffs for it to sit in. There's no screws at this point that hold it in place. It just drops in. And then we have our lid, which goes over the top, that we can then screw down. It seems that they're including a smaller potentiometer now than they have in the past. There's a big hole for the potentiometer there. Yeah, it's a little small one. I could always 3D print a bigger one for that if I wanted to later. Before we do this though, we need to connect up our foot switch. Our foot switch is used for our manual control over it. It does have automatic control as well, but I'm gonna want to install the foot switch because I think it's a nice feature to have. What we do need to do though is peel this back because they haven't actually cut the sheath back on this. Now the connector for this is this one here. You're going to need to get this in, and you want it as short as possible because you want to be able to cable tie the cable through there to offer some strain relief. So what we need to do is very carefully just get the two wires in like that. Tighten it down. This connector isn't designed to hold it in place. It's simply designed to obviously give you the electrical connection, and then we want our cable tie that we're going to place through it. We'll have to probably pop this out of the base to do this. We're just going to very carefully give that a little bit of a pop there. A little bit there. As I said, there's no screws that hold this in place, so that allows us to get it up. There we go. So we will simply pop that through. Just like that. And then that's going to give us our strain relief. And then what we're going to do is use our pliers to start to pull down on the cable, obviously snip it. So that then is going to give us our strain relief down there. You're still going to have to be a bit careful with it. You know, you're not going to want to tug on it too hard because you're still going to break it. But that there gives us a nice amount of strain relief. There we go. And then we can pop him back in the case. So now all of that is done. I'm going to peel off this little bit here from the display. Pop our lid on top. Carefully just getting this into the right position. Giving it a bit of a push to make sure it all fits in nicely. That's looking good. And I'm going to use these extra screws that I found in the kit. I don't know if they're for this, but I'm going to use them for it regardless. When it comes to choosing a power source for your kWeld, you're obviously going to need something that is able to deliver that massive amount of current in a short burst. You ain't going to be powering this off a small 12-volt supply. You're going to want something like this big lead-acid battery here. You can potentially run them off lipos as well. I'm going to be using this 100 amp leisure battery. This is delivering a decent amount of current in my testing so far, about 1300 amps, although using a battery like this does have a couple of big downsides, its sheer size and weight on the bench being the biggest. Ideally, you'd want to do something like this and put it on the floor, but that then means you're extending the cables, which then means you're reducing your available current. They do talk about in the instructions being able to use some LiPo batteries. They do mention that you could use something like a small 3S. This is a 4S. I haven't tried it with this one, but you could give it a test. I did try it though with quite a big 6 amp 6S battery that I had. This was an old one which was towards the end of its life. This unit does support up to 30 volts of input, so that means I was able to use this, but unfortunately in every test it actually ended up melting the interconnects between the cells. The first time I tried it was on full 6S and it melted the interconnect. I then split it into two 3S packs and fixed it, and then it melted the interconnects on both of these again, so I've given up on using these LiPos. However, if you want the best solution for your welder, Keenlab have what they call their K-cap ultra capacitor module. This is an ultra capacitor bank that will store the energy for the welder. The way this works is you power it off a current limited power supply in the voltage range of 8.1 to 14 volts. This will then store the energy in these massive ultra capacitors, and this can provide up to 5,000 watts of power into 3.3 milliohms of load. It has a typical short circuit current of 2,400 amps, and as I've said, this allows you to use it with any traditional 12-volt power supply, but it is very important to note that if you are going to use this, you must use it with a current limited supply. You cannot use this with an unlimited transformer supply or something like a battery. It needs a current limited input to restrict the amount of power that it can draw. It can be up to 70 amps, but it must be limited to no more than that. What's nice about this though is it gives you a real nice clean solution. They show on their website a couple of options around it, so it's a kit that includes all of the accessories you need, and you can actually build it into a nice kit with a fan on the top as well, and this just makes a much cleaner solution compared to using that big lead acid battery. Now, unfortunately, I didn't quite have enough money to order that at the same time as ordering this. So as I've said earlier, I'm going to be using this big lead acid battery, but that capacitor bag is definitely something I'm going to look to invest in the future. And it also allows you to have just better and faster performance from the welder as well. So if you're looking to do this very regularly, you definitely want to give it a look. So I'm going to power the unit up first of all. I've got these on individual tails. So this one is plus with the red tape on, and this one is negative with the black tape on. It's actually opposite to what we've got over here on our battery, but we'll be able to plug these in. Now, when you power this up for the first time, it should show Cal on the display like that. If it doesn't, you can go into the menu and manually select it, but the first time you power it up, it should show this Cal option. But if it doesn't, simply press the button on the unit, scroll through until you find Cal, and then you're ready to proceed. The first thing you need to do is then press enter, and you can now see that it says open. What they mean by this is to calibrate it with the probes open, not connected. You can trigger this either by pressing the button again or actually pressing on the foot switch, which I've got here next to my hand. So what I'm going to do is press and hold. It says OK, and if you actually press and hold down, it will give us the information for the offset. So you can see it's set an offset of 59 and then release. The next part of the calibration process is doing the same thing, but this time with the probes shorted. So what I'm going to do is place the probes together, holding them really tight, making sure that they're not going to slip or anything like that. And then what we're going to do, and ideally I don't want my finger on the probe part, so I'm just going to hold it like that there, making sure that there's plenty of contact. I'm going to press and hold again, and whilst I hold it down, you will see that it'll give us the information from that test. You can see it's scrolling through, telling us various pieces of information. So it says OK, it gives us the resistance, it gives us the amount of current, and it gives us the temperature, and it tells us it's okay. The important thing to look at here is the amount of current that was drawn. If you remember earlier, I said the maximum that this unit can deal with is up to 2000 amps. In this test, it allowed, what was it? Let's just get back to it. I think it was 1359 amps. So whilst we're not up to the maximum, we're not over the maximum, and that actually should be plenty for us to be able to start welding. Once that's done, you simply hit release, and then the initial calibration is done. Now, you shouldn't have to recalibrate this all of the time if you're using the same battery. But if you were going to change the battery that you use with this system, you do want to perform a calibration beforehand. Once it's finished, you can see it sits here onto this display that says E. This is the energy rating, and this is the current setting that we have for the welder. Now, if I press the button, we can go back into the main menu and we can scroll through all of the options. So, for instance, the first option is mode. We can set it to auto or go back in and press it and set it to manual. You've then got the option for trigger delay. I've left this at 0.5 seconds, but if you wanted to change it, you can. You've got default energy rating. This is the default energy rating for the power output. It will turn on to. It will probably set it at 10 joules initially. I'm set it at 35 because that's what I have found for my welding that I've tested so far. Looks good, but you will need to play with this. But this is the default option when you power it on. You've then got cable length. This is done what the cable length for the probes are, including this area here. This is the standard option, which is set out at 1 meter. But if you did add longer cables, you can adjust that here, and that will help the unit correctly configure itself when it comes to its power output. You've then got low battery warning, which you can set a voltage for. So for instance, we could set that down to a 10. We could set that to 10.3 volts for our battery. Then you've got minimum current setting. So what to say is not enough current for the unit to work. That's currently set to 800. You've got an option to change the direction of this encoder, so you can change it from clockwise to anti-clockwise. You've got your serial connection option, your board version. So for instance, this tells us the version there, and our firmware update option. Now that calibration is complete, we're ready to start doing some welding. As I mentioned, I've bought this to be able to build myself some lithium-ion packs for flying, whether it be 18650s or 21700s. To demonstrate this today, though, I'm not going to be using these batteries. I'm not quite ready to build them yet. I'm still waiting for some stuff to come, but I am going to do some testing, and we're going to practice on some traditional AA batteries because you can get them really cheap, and it's the same process to weld to a bottom of an AA battery as it is to one of these. Now, to be able to connect our batteries, we need nickel strip. I ordered in what I believe to be pure nickel strip. We've got 0.2 thickness in this bag here and 0.15. Both of these are 8mm wide, and we're going to be testing with both of these on the welder. Rather though than testing on some lithium-ion packs, we're going to do some testing on some old AA batteries. We're going to be welding to the base on these rather than actually wrecking some 18650s or 21700s. These are really good for practicing. You don't have a lot of space on the top, but there's plenty on the bottom, and we'll be able to use this to test how our welds are working, how strong they are, and then we'll see how it performs with both the 0.5 and the 2.0. Now, I'm holding my battery in this little roll of solder, and I've just got a bit of foam in there to hold it in place. And we will start with our 0.15 strip. I'm just going to try and cut a piece of this off. There we go. There. And what we'll do is we'll test it on the 0.10 mode, and we'll see how that holds up. And then we'll move up the power ranges just to give you an overview of how it works and how well the welds come out. Now, I've currently got it in the manual mode, so I've got the foot switch on the floor. And what we're going to do for the welding is pop our battery there. And then what we're going to simply do is pop our probes, our electrodes, onto two positions on the strip and the battery. I'm just going to hold that in place. I'm then going to press down on the switch. You can see if I hold down on the switch, it did it. You can see it gives us the information. So we used 1100 amps on that one, and it went to 28 degrees C. And you can see that that has welded, but it hasn't welded very strong. So for instance, if I just give it a bit of a tug, you can see I've been able to rip that off, and that is because we didn't have enough power in the weld. If we now go up to 25 joules, we'll try again at that number there. So let's give it a go. Make sure we're in the right place. You can see there that it says it's used 1180 amps on that one. Whilst it's definitely welded, it doesn't look particularly strong. Let's pop him off. You can see that that's starting to tack now, that it is gripping, but it isn't super strong. It's getting there. It has torn a hole on that one, which is a good sign. What we're basically looking for is the welds to be strong enough and actually tear out when we pull them off. We're not quite there yet. We'll do the same thing again, but this time I'm going to go up to 35 joules. That's what I found was doing a pretty good job when I tested it earlier. So we're going to go to 35. I'm just going to press down nice and hard and then onto the switch. You can see we got quite a spark that time. And now that is definitely starting to look better. If I show you that there, you can now see the weld definitely looks like it's penetrated more. If I get my pliers now and give a tug on this, that's a really good sign. We're actually tearing out the metal strip. That tells me that we've actually got a really good hold on that. So for this 0.5, that seems to be the sweet spot. Fresh battery and a fresh piece of strip. We can lay it over the top. And what I'll do now is keep the settings the same, but we'll do a number of welds on this. So we'll go in there. I'm trying to find the foot switch. Here we go. We're going to come across to this side here, putting pressure on. Good again. You can see we've got 4 welds. I'm just going to go either side there as well. And if I get that under the camera, you can see that those welds do look like they've penetrated nicely. So we got 6 welds on it. And if we now try to give this a tug, that's good. We're tearing out. I'm not saying it couldn't be a bit better, but I'm quite happy with them. They're definitely welded. They're definitely penetrating into the bottom of the battery. So next we're going to try our 0.20 strip. Now we'll try it on the same settings, but we might need to up the power. The welder is absolutely capable. It comes down to your power supply, if it's going to be able to handle it or not. We'll go with the 0.20 there and there first. So I'm going to put some pressure on, go for the switch. I'm going to go for 4. Doesn't look like it's penetrated as much as the 0.5. Yeah, it is pulling out. It hasn't 100% torn through. So we're definitely going to want a bit more power. Grabbing a fresh battery, what we'll do is we will try again, but we'll up the power this time. So I think we'll try... Let's go to 50 for this and see how the 50 gets on. We may, though, come up against the limit of my battery on this one. Let's see. Okay, we still got in there at 50. I didn't actually look how many amps that drew. We'll do another 2 and then we'll check that. If I hold the switch, how many amps did we get in at 50? Nearly 1200 amps. So there you can see we've welded in. It doesn't still look as good as what we had earlier. Before we tear that off, what I think I'm going to do is go back to this one. So we're back to that first battery we used. So let's go up to, let's try 60 joules. Let's see if we can get that in. Pressing on. Bigger spark that time. Definitely. Pressing on. Try to... So there we have the first versus the second one. So if we try that first one, I think this was... Let's just see how that is. It's definitely on there, but it's not pulling out quite as much as I'd like. Oh, the 50s have, for sure. And then let's now try the 60s. That's really looking good. That's perfect. I don't need to tear it all off. You can see it's ripping holes in the metal. At that point, that's as good as you're pretty much going to get. So you're trying to make sure that the mechanical strength is there in the weld. That's looking really, really good. So, as you've seen, it's all working, it's ready to go, and in the next video, we're going to be doing my builds. I've got a bunch of stuff coming from AliExpress, a load of different sizes of heat shrink tube. We've got some isolators to go on the top of the batteries, some fly leads that we need for the balance ports as well. That hasn't quite arrived yet, so at this point, we're not going to be making my packs, but I am going to be doing that in a dedicated video in the very near future. As I've said, this is one of the better options available on the market. If you're interested in getting one, it is available from kWeld's website. Price of the kit will depend on the options you choose. I went for the complete kit up here. I chose it for the cables to be pre-assembled, which comes in at 177 euros. You can put those cables together yourself for 169 euros. For 8 euro, I personally don't think it's worth it, and as I mentioned earlier at the beginning of the video, you just don't want to mess around with getting that bit wrong, because the entire resistance of the circuit is based around that fitting. So if you're interested, it's available for 177. As I did mention, they also have their capacitor bank is available as well. This is available for 129 euros. That is a real nice option, and I'm going to get myself one of them probably towards the end of the year once I've saved up a bit more money. They also do have a number of other accessories on their website too, if you're interested in checking it out. And you can also buy just the electronics if you want to as well, and build your own kit up. That kit board is available for just 129. So that's it from me on this one. I hope you found it interesting. Please do let me know what you think in the comment section. Finally, I just want to say, if you'd like to support the channel to allow us to keep doing things like this kind of stuff is expensive to buy, and if you found it interesting, please consider checking out the links to my Patreon as well as buy me a coffee. It is only through the support of my patrons am I able to keep making content on this channel, and if you'd like to support us, there's a link in the description. I want to say a massive thank you to all of my Patreons. We would not be able to keep doing this without the support you've given or the donations that we get through buy me a coffee, so a huge thank you from me to you. Anyway, that's it from me on this one. Stay safe. I will speak to you soon.